vertical asymptotes of rational functions. Our objective, we want to identify vertical asymptotes in the graphs of rational functions. Well, let's begin by recalling what we already know. We know what a rational function is. It is a quotient of two polynomial functions. And the key to rational functions is that because it's a quotient, because it is a division problem, the denominator cannot be zero because division by zero is undefined. All right, let's start off with defining what an asymptote is. An asymptote, funny word, I'm not really sure where it comes from. An asymptote is a line that guides the graph of a function, but is not part of the graph of the function. All right, and here's an example. Okay, so this function here on my sheet is blue. This function comes down from positive infinity, and as x increases, it curves, and then it goes along to positive infinity as x increases, and it hugs along this this line here, which is kind of shaping what happens with this curve as x goes to positive infinity. Okay. Asymptotes can be vertical, horizontal, or slant, also called oblique. Okay, so obviously a vertical asymptote is going to be up and down. We're discussing that now. A horizontal asymptote will be left to right, and a slant asymptote or an oblique asymptote is any other line that's not horizontal or vertical. So we've defined an asymptote. Let's define a vertical asymptote. Vertical asymptote is a vertical line, and every vertical line has the equation x equals a number. It's a vertical line that guides the graph of a function, but is not a part of it. Okay, in application problems, a vertical asymptote occurs whenever there is a zero in the denominator. And we talked about that in our previous lecture, that zeros in the denominator mean that the equation or the function is undefined, okay? Well, we're gonna have a vertical asymptote there. That's why they're undefined. It can never be crossed by the graph because it occurs at an x value that is not in the domain, that cannot be put into the function. So you can't connect it to a point. Rational functions can have more than one vertical asymptote, all right? These four examples have a single vertical asymptote, x equals a, here, 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 and here. And you can see this graph, as you come in from the right and go up, it'll go closer and closer to that dotted line without touching it. As you come in from the left and go up, it'll go closer and closer in this example. And similarly, you can also come closer and closer and then be directed down from either direction. Okay, so let's take a look at some examples and how these vertical asymptotes look on our graph. Algebraically, find the vertical asymptotes, if any, of the graph of each rational function. Use your graphing device, and we're going to use Desmos to check your answer. Okay, vertical asymptotes correspond to zeros in our denominator. So let's look at the denominator and let's find out when is this denominator equal to 0. Okay, got to solve for x. Let's start off by subtracting 4 from both sides. And now we're going to divide both sides by 5. And we have x is equal to negative 4/5. Okay, so this denominator is 0 when x is equal to negative 4/5. So negative 4/5 will not give us an answer, will not give us an output value. And it tells us there is a vertical asymptote, I'll abbreviate that with VA, at x equals negative 4/5. Okay, let's take a look at that on our graph. me get my my Desmo set up here. I think I got us all good. Doesn't look particularly clear, however. Let's try. There we go. Okay, so we got Desmos going. Let's go into here, and we'll do a y equals. I need to press my division key. The numerator is just x. The denominator is 5x plus 4. Okay, you can see there's my graph. Okay, and you can see there's a vertical line shaping the graph that goes right through here. Okay, I'm going to kind of come in a little bit. Okay, I can kind of go that way, but I'll kind of come in the x and kind of give it a little less y, I hope. Okay, so there's a vertical line. As the graph comes in from negative infinity, it goes up and it starts to hug a vertical line. As the graph comes in from positive infinity, comes in from the right, it goes down and hugs the vertical line, never crosses it. And we think that vertical line is x equals, so let's graph it. X equals negative 4/5. And there you can see in red that vertical line. As we come in a bit more, okay, let's look at the upper portion of it. You can see the graph is coming in and it's getting shaped by this vertical line. It's getting closer and closer to it. It's never going to touch it. It's never going to cross it. And the same thing as it comes in from the right here, it's getting shaped by this vertical line. It's never going to touch it, though it's getting closer and closer and closer. Okay, let's look at a second example. I had to correct my paper, so pardon me for that. G of x equals x plus 2 over x squared minus 9. We want to find vertical asymptotes. Well, we're looking at the denominator. When is the denominator 0? Okay, x squared minus 9 equals 0. Let's add 9 to both sides. Isolate the x squared term. Let's square root both sides. And we have x is equal to, don't forget, positive or negative 3. Okay, we have 2 vertical asymptotes. There are 2 vertical asymptotes. One at x equals positive 3 and one at x equals negative 3. So 2 numbers cannot be put into our function. They are both undefined. And if they're undefined, they are vertical asymptotes in the graph. Am I clear? Yeah, let's take a look. So I'll go back to here and get myself situated. I can get rid of the second line. Let's go to my first line. We'll just kind of fix this one. We'll just kind of adjust this one. X plus 2 in the numerator. And the denominator, whoops, I can't touch it very well. The denominator is x squared minus 9. Okay, there we have it. Let's scroll in and you can see I'm coming in and you can see here there's a line shaping the graph right here. As it comes in from the left, it goes down and hugs that line. As it comes in from the right, it goes up and hugs that line. And there's another line shaping the graph, another vertical line shaping the graph right here. As it comes in from the the left, it goes down and hugs that line. As it comes in from the right, it goes up and hugs that line. And we know those 2 lines are x equals 3 and x equals negative 3. And you can see right there, there's your x equals negative 3 shaping it like we saw in the previous example. And here in the blue, there's your x equals positive 3 shaping it as we saw in the previous example. And then again, there's your entire graph with the vertical asymptotes included. Let's do one more example. Letter C here. Okay, I think I got you going. Okay. Find the vertical asymptotes. Okay, that means we're looking for zeros in the denominator. X squared plus 9 equals 0. Let's get the x squared isolated. Subtract 9 from both sides. X squared equals -9. Okay, we can stop here. We realize that in the real number system, every time you square something, you get a positive. There's no way to square a number and get a negative. Or we could continue with our calculators and take the square root of -9, and it would tell us, thank you, but no thank you. That's an error. I cannot do that. And so this tells us there will be no zeros in the denominator. Every x value is good. And so there are no vertical asymptotes. Okay, let's take a look at that. We'll see that in just a second here. Let's put it into our graph. I'll get rid of those. Come up to here, and let's just adjust this one. The numerator is x plus 3. The denominator is x plus 9. And you can pretty quickly see that there, or I can zoom out, and you can see this graph is really hugging right along the x-axis. There you go. It's kind of strange if you get in real tight. See what the graph does. But there's nothing here that is showing a vertical asymptote. There's no break in the graph where the line is going to a positive infinity or down to negative infinity. There's just a little hiccup right there around the origin. Okay, so there you have it. Zeros in the denominator are vertical asymptotes in the graph when we're talking about applied problems.